So we are assessing a project which create externalities, external benefits or external costs. So in our NPV calculation, we need to include this external benefits or external costs. So it is necessary that we put a dollar value on these items, or we value these items. However, one difficulty here is that these items either is a benefit or costs, like pollutions due to a project. One difficulty here is that they generally do not have a market, so we cannot put a dollar value on top of them that easily, in a sense. Fortunately, we still have a number of techniques we can use to value them. One of them is called hedonic price approach. Okay, the idea here is that, say my project creates pollution to the societies. So what's the dollar value of the pollutions? I don't observe it directly, but I can try to infer this dollar value from something that I observed. For example, like land. Okay, so like land or house price change. Okay, let's look at examples. Okay, land adjoining reserves or in areas that are quiet generally have higher prices than the identical block elsewhere. Identical. Everything else are the same except one is close to the reserves or the other is somewhere else. Thus, the price differential measures willingness to pay to enjoy a certain environmental benefits. Conversely, land under the light path is cheaper than the identical block elsewhere. So the price difference will measure that the light, for example, pollution of light. So the idea here is that the value of an environmental good or bad can sometimes be calculated by observing property values. For example, suppose we want to estimate the cost of aircraft noise. So this is the airport, okay, and we can map noise contour here. For example, the closer we are to the airport, the higher level of noise it is subject to. The further away, the less noisy it is subject to. So we can kind of create a contours of this. For example, maybe say we have a house here, house 1, and house 2, and house 3. Then it'll be house 1 and house 2 are subject to same level of noisy, which is higher than house 3. Okay, and we can collect data of house prices of them and house characteristics. Okay, then we form a model of house prices. We try to explain house prices as a function of its characteristics, accessibilities, neighborhood features, and the pollution variables. In our example here would be noise levels. Then we got the data. We can estimate the functional relationship, and we can find that if pollution is high at P1 level, then house price is on average is this. If pollution is at P2 low level, the house price on average is this. Then the difference in house prices is due to this pollution level change. If if our project said create this many pollution change, and then the dollar value of this item would be change of house price here. Okay, let me use an example in Excel. So suppose our task is to estimate the dollar value of 10% increase in air pollution due to a project we want to assess. Okay, and we can use this hedonic pricing approach. Okay, so first, let's set up the models log price as a function of NOx, which is nitrogen oxide, and that's the variable we use to measure the air pollution. And distance to the distance of the community center to the employment. Suppose that's one characteristic of the property we are looking at. And rooms are the number of rooms that the house has. And ST ratio, student-teacher ratios, which is average student-teacher ratios in the schools of the particular communities, plus in L terms U here. Okay, so then we go to collect data like this. Okay, price, NOx, rooms, distance, student-teacher ratios. All right. So we set up the model of this and collect data and transform variables. Okay, so we transform from price, we transform log price. So log of A3. Similarly for this, for the NOx, rooms, let's decide not to transform. Okay, so room is number of rooms, and distance, student-teacher ratios also untransformed. So that's the model we are going to estimate. Then estimate the model using OLS, and here I already estimate the models. Okay, so let me just illustrate here. So you go to data analysis, and choose regression. So input dependent variable is the price, input X, that's it. Exponential variables, independent variables, that's this. And notice that my selection include the labels. So I'm going to tell Stata that's the case. I'm going to output the results, the estimation results, the OLS estimation results to a new worksheet. So it's okay. There you go. That's the estimation results. Okay. So the estimation result the same as here. Okay. We are interested in the coefficients here. So basically now it says that my estimation log price is equal to roughly 11 minus 0.95 log NOx plus 0.25 rooms minus 0.13 log distance plus minus 0.05 is student-teacher ratio. Okay. So now we can use this result, and by the way, they are statistically significant at the 5% levels. So now we can use this information to estimate the dollar value of the pollution, air pollution. So use the estimation results to estimate the dollar value of the increase in the air pollution due to this project. So we get this. So parameter interested is the coefficient of LNOx, which is negative 0.9535. So this says that a 1% increase in air pollution results in 0.95% increase in the median house price. So as we know that the project will increase air pollution by 10%. So on average, the house price will decrease by 10 times 0.95%, which is 9.5%. Okay, and we can also calculate the sample average of house price, which is this many. So average of house price of from A3 to A508. So therefore a 10% increase in air pollution results in a reduction of average median house price by this many. So $242,146. And then we suppose that the project affects 500 houses, and this parameter we can estimate from the data we have. Then the dollar value of the air pollution is 2,146 times 500, which is over $1 million.